Um, Actually, it's quite simple. The idea behind Erasmus Mundus is that it's a master program organized by consortia of at least 3 European partner universities. So in this case, it's Uppsala University in Sweden, TU Berg Academie Freiburg in Germany, and Ghent University in Belgium, which is the coordinating institution. Graduating from an Erasmus Mundus program means that you receive a joint diploma. So joint means signed by directors of all consortium partners taking part in the program. And you get your diploma by traveling Europe. What does that mean? 1 or more semesters you study at the coordinating university. So that would be Ghent. And at least 1 semester at one of the partner universities is part of your curriculum. So mobility is inherent when you choose for an Erasmus Mundus program. I now give the floor to Professor Gijs Dulin, who is the academic coordinator of the SINReM program, who will introduce you to the consortium partners of SINReM.
Thank you, Leen. I'm happy to see so much interested candidates here in this session today. So indeed, I'm going to give an overview of the program. So starting with the partner universities. So we have 3 main partners from within Europe who all award the diploma. And this is Uppsala University, TU Berg Academie Freiburg, and Ghent University. And they all bring in specific expertise in the program. So Uppsala University brings in knowledge on the exploration of rare georesources and on innovation management and entrepreneurship training. So Uppsala is located in Sweden, about 80 kilometers north of Stockholm. Then we have TU Berg Academie Freiburg, which is a university who has a lot of expertise in sustainable and environmentally friendly extraction technologies. So this is previously a mining university located in Eastern Germany, not so far from Berlin. So they're very specialized. It's a very specialized university. And then we have Ghent University, who has the expertise, brings in the expertise on circular economy, environmental science and technology, and recovery of resources from wastes and sustainability assessment tools. Yeah, so as I mentioned already, TU Berg Academie Freiburg is a mining university. Freiburg is a not so big town, very small town, but there was previously a lot of mining in that area of Eastern Germany. And so the university still has a mine, an experimental mine, a below ground mine, where experiments can be done in situ. For example, bioleaching experiments can be done in that experimental mine. Freiburg is also very well known because some very important chemical elements were discovered there. For example, helium was discovered there, which is an element. Indium was also discovered there, which are elements that are very important in the technologies nowadays. Yeah. Next is Uppsala University. Uppsala University in Sweden is also a very famous university because some very famous scientists were working there, some Nobel Prize winners. And then we move to Ghent University. Ghent University, which is does not have as much famous scientists as Uppsala University and Freiburg University, but we have also a very highly ranked university, very well known in the field of agricultural sciences, food sciences, and environmental science and technology. And so these are the expertise fields, mainly environmental science and technology, which we bring into the SINReM program. Yeah. Then I will say something about the content and the scope of the program. So I think you are all here because you all want to tackle global problems, problems such as climate change. We are confronted with waste emissions and with increasing population and urbanization. So this results in resource scarcity, and we have problems. More and more problems with the sustainable food supply. Yeah. So there are solutions to that. One thing we could do is we can change the society completely, start from zero and build up a new society where we share more goods, for example. But the issue is that we have a lot of lock-in of individuals because there were a lot of very capital-intensive investments done in the past. So as an alternative, we can move from a linear to a circular economy, a circular supply chain, where we introduce concepts such as industrial symbiosis or urban industrial ecosystems, where the waste of one part of the system becomes a resource for another part of the system. We are also developing smart cities. We think of smart logistics, sustainable buildings, green energy, and green mobility solutions. Yeah. But of course, all of these solutions should be sustainable, and the sustainability focuses on meeting the needs of the present without compromising the ability of future generations to also meet their needs. And this concept is composed of three pillars: economic, environmental, and social, also known as profit, planets, and people. So we have to make sure that when we build solutions, that these are not technically feasible only, but they also, you have to think of environmental, social, and economic impacts. And we also have to take into account that resources at some point are scarce. When we look at technologies, for example, a windmill a few hundred years ago, the amount of materials we needed to build that windmill were relatively limited. We could work with iron, carbon, wood, for example, zinc. But when we look at solutions nowadays, for example, green mobility solutions, green energy solutions, we have to take into account that the amount of materials which is being used in these technologies is much higher, and there's a much higher diversity. So the materials have become much more complex, and the solutions have become much more complex. So we're using a lot of exotic materials also. And when we then look at the materials being used, we have to take into account that when you look at a particular world region, such as the European Union, for example, that for each of these materials, there is an economic importance, and this economic importance can be low or high. For example, for magnesium, the economic importance is very high because magnesium is used in a lot of lightweight materials to make cars lighter, to make planes lighter. We use a lot of magnesium, so this has a very high economic importance, this element. But you also have the supply risk for this particular region, and this is now the European Union in this graph. So, for example, for rare earth elements, the supply risk is very high because rare earth elements are supplied only or mainly through China, for example. And if China controls 95% of the supply of rare earth elements, then there is a very high risk. If China decides not to supply these materials anymore, then Europe is confronted, and also other world regions are confronted with a serious problem. So you always have a supply risk, which can be high or low, and economic importance can be high or low. And of course, if you combine a very high economic importance with a very high supply risk, then you have what we call critical raw materials for the European Union, but you can also do that exercise for other world regions. So that's why, because we have these critical raw materials, that's why Europe decided to make a network of companies, universities, and research institutes focused on a sustainable supply of these critical raw materials. And when we talk about sustainable, we mean not only economically sustainable, but also environmentally and socially sustainable. And this network is called EIT Raw Materials. And so I'm explaining this because the SINReM program is financially supported also by this EIT Raw Materials network. Yeah. So what can we do to go towards a more sustainable supply of these critical raw materials? We can explore new environments. Yeah. We can optimize processes. We can optimize extraction processes, for example. We can substitute materials. So if we have in a particular technology a material which is considered to be not so sustainable, and not sustainable can be not environmentally sustainable, not economically sustainable, or not socially sustainable, or a combination of the three. We can substitute these materials by materials which are more sustainable. And then we can also think about recycling to put the materials in the loop. So if we have e-waste, for example, we can recycle that e-waste to reuse the materials which are inside these wastes, which also reduces the waste emissions, of course. And that's how the program, SINReM program, is actually built. So you see that the program is built around this raw materials value chain, with expertise from Uppsala being brought in on exploration. Then we have expertise from Freiberg being brought in on the optimization of the processes. And then Ghent mainly brings in substitution and sustainable materials and recycling technologies. Yeah. To develop these sustainable solutions, we realize that we need to train T-shaped professionals. What does that mean? Our graduates should have broad knowledge and skills on the entire raw materials value chain, combined with deep and specialized knowledge on and skills on particular aspects of this value chain. So a broad view combined with a specialization in a particular field. And that's what we call T-shaped graduates or professionals. This broad view or this broad knowledge is brought into the program by training the students in the first year in all aspects of the raw materials value chain. So students go to Freiberg, go to Uppsala, and go to Ghent. And in Uppsala, for example, they are trained in geo-resource exploration. In Freiberg, they are trained in sustainable processes. In Ghent, they are trained on resource recovery, sustainable materials, circular societies. And then we also have entrepreneurship in Uppsala. So this is all in the first year where we want to train or give the students this broad knowledge and skills. And then in the second year, students can decide to specialize in one of these particular fields. So they have to choose a major on exploration, a major on optimization, a major on resource recovery, recycling technologies. And so they decide to go to Ghent, to go to Freiberg, or to go to Uppsala in the second year. So first year, students move as a cohort from Freiberg over Ghent to Uppsala, back to Freiberg, all together in the first year. In the second year, they have to choose a major where they are being further trained in one particular field, and they also do a master thesis in that particular field. Yeah. So you see that we want to achieve a multidisciplinary cooperation in a global perspective. And that's why we say that we are not a pure mining program, we are not a pure geology program, we are not a pure material sciences program, not an environmental engineering program, also not a chemical engineering program, but we want to stimulate interaction between people having these different backgrounds and learn from that interaction how we can make the entire raw materials value chain more innovative and more sustainable. So that's what we are doing in our recruitment also. We don't want to recruit only environmental engineers, but we want to have a few environmental engineers in our program. And they have to work together with geologists, with mining engineers, with material scientists to develop these sustainable solutions. Yeah. To just illustrate that we have that multidisciplinary cooperation and global perspective, on the left side in this table, you see all the various backgrounds we have recruited in the past years. So students with bachelor degrees or also sometimes master degrees in these different fields. On the right side, you see where the students came from. So you see that this is a global issue we want to tackle. So we are recruiting students from all over the world. So now quickly, how does this look like in practice? So we start with the kickoff in Ghent, and then students move for 3 weeks to a block course on Freiberg, and this is organized September, beginning of October, on chemical principles and sustainable technologies along the raw materials value chain. Then they come to Ghent for a few courses an economics course, but also course on recycling technologies, on training in particular tools for sustainability assessment. And then after that, students move to Uppsala, where they focus on mineral exploration, innovation management, and entrepreneurship, and can follow some elective courses. So you see that we are training students first in recycling technology, then in georesource exploration. This is not very logical, but it's possible, and it's coming from this practical arrangements. We also, of course, have to take into account practical aspects. And then at the end of the first year, students go back to Freiberg in June, July for 6 weeks or 6-7 weeks to continue the course in Freiberg. Then in the second year, we have a mandatory internship. So all the students have to follow an internship of at least 5 weeks in the non-academic sector. It's mandatory. So this is also an asset of the program. EIT Raw Materials, this network in which we are embedded, requires that also, that every student has an internship. And then we have several majors. We are reorganizing the majors a little bit right now, but the principle is indeed that you have to choose between Ghent, Freiberg, or Uppsala for a major, and then also conduct your master thesis work in line with that major. There's also one online course in Freiberg that organized by Freiberg that can be followed from any of the countries which are involved on financial and sustainability reporting, financial planning, and business evaluation. If you want to learn more on the experience of SINReM graduates, I can recommend you to go to the SINReM website, where there is the option also at some point to chat with some of our graduates. So there is some kind of a chat box there. This is organized by EIT Raw Materials, so you can also reach students who graduated from other EIT Raw Materials supported programs through that system.